So topic metal, topic 9, which is the metal topic. You can annotate on the screen. You can also use a chat to answer these questions. Some elements are there, as you can see. Some elements are shown in order. They appear in the reactivity. The most reactive metal element is at the top, and as we go down the reactivity. Answer the questions using a list. Each element can be used once. It can be more than once or not at all. So the first one, which is a non-metal. So which one is a non-metal here? You can find hydrogen is a non-metal. A metal which is stored under oil. So the group 1 metal, because they have low density as well as highly reactive, so stored under oil. The main component of the steel, steel, which contain iron, carbon, and stainless steel, nickel, chromium is also there. But the main component, the base, is the iron. A metal with 3 electrons in the outer shell. So which metal? It means a group 3 metal they're asking. So in that case, we will have aluminum. And metal found in a brass. So metal which we found in a brass, that is copper and zinc. A metal that form a chloride with the type Xl2 and Xl3. Which metal can form? So that could be iron. The reason, because the list is on the other page, that's why it's called. So this is correct. Iron is there. Name the main ore of aluminium, of zinc. What is the ore of zinc? Naturally, so zinc blend, that is a naturally occurring compound. And what is the main ore of aluminium? That is bauxite. In an experiment, a sample of a zinc appeared less reactive than expected. So because it has unreactive, or you can also say protective oxide layer, because whenever we have a piece of aluminium, even this oxide layer is there with magnesium as well. When you have a magnesium ribbon, with the passage of the time, magnesium react with air, oxygen, and it will form a magnesium oxide. Same thing, the top layer of aluminium is aluminum oxide, which is unreactive. Name 2 metals from the list which are expected by reduction with ore of the carbon. I will scroll to the page. Zinc is correct. Iron and zinc. Because when you find how you will work out like which can be reduced by carbon, they should be less reactive than carbon. So on page 8, this was a list. So when we check the position of a carbon, carbon is between aluminium and zinc. Like this is the position of a carbon. So we can use zinc, like carbon can be extracted to remove, extract zinc from its oxide, iron, or even copper. Zinc granules are added to aqueous copper 2 sulfate. The reaction occur or reaction happen. During a reaction, a red pink solid and a solution become colorless. Name the red pink solid. So what actually happened here? We have a copper sulfate solution. Remember copper sulfate, the color of a copper solutions are very important. So copper sulfate solution is blue in color. When a zinc metal is added, as we know, zinc is more reactive, so zinc will displace the copper, and as a result, it will form zinc sulfate. Zinc sulfate is colorless, and it will form a copper metal, which is brown in color. So red, pink, or brown, this is the color of the copper. The colorless solution is due to zinc sulfate. Explain in terms of the particles why the rate of a reaction increases when the temperature increase. So Particles gain more energy, they will move faster, result in more collision, result in great. Another important point, that there will be greater proportion of the particles which have energy more than activation. So particle gain energy, they move faster, that is fine, more successful collision, but there's another point which you always try to refer whenever you increase the temperature, that there will be greater proportion of the particles which have energy more than activation, like this point. So more particles have energy more than activation, so rate will increase. State two other ways to increase the rate of reaction. How we can increase the rate of a reaction? Two other ways. Increase the surface area. It's already granules were used. Temperature is there. Concentration you can mention. Catalyst you can mention. Increase concentration, right? Using a catalyst, that's also correct. The next one is related to zinc. The detailed explanation of a zinc is not part of the syllabus, like they were, but in terms of reactivity, you should know, like how zinc is extracted, the whole procedure is not there. But the ore of a zinc, how the reaction of a zinc happen, like the as a different metal, that is still part. So state the name of a ore. So zinc blend is there. The ore is converted into zinc oxide and then it is reacted with carbon. Write a chemical equation for a zinc oxide and carbon. So if we have zinc oxide and it is reacting with carbon, so we can complete a product, we can complete carbon monoxide, or we can also complete as a carbon dioxide. State what happened, what type of a chemical change happened to a zinc in zinc oxide. So what happened to zinc in zinc oxide? Is this oxidation or reduction? Because it's a removal of oxygen, so you will say reduction. But whenever you write your answer, yeah, oxygen is removed, that's fine. But whenever you write your answer of oxidation and reduction, the best definition is the in terms of electron. Even though it's not wrong, but whenever you write about oxidation or reduction, always try to use the electron terms of electron rather than oxygen. So mention because this is reduction because it's a gain of electron. If you say if it's an oxidation, then it will be a loss of electron. So whenever a question is there about oxidation or reduction, always use the term electron. Don't try to include oxygen, hydrogen, or even oxidation number in your explanation. Explain why aluminium is not extracted from aluminium oxide by heating with carbon. Because aluminium is more reactive. That's right. Suggests an alternative method of extracting zinc from oxide. So we can use electrolysis, but you have to mention electrolysis of molten zinc oxide. If we do electrolysis, brass is an alloy of a zinc. In terms of the particle, why brass is harder than a pure? Like why? This is also a question why alloys are harder than the pure metal. So 3 marks are there. How you write this answer? First thing you will mention, alloys are mixture of different metals, mixture of the metal. And in the lattice, there are different size of ions are there. So in a zinc, a regular lattice, which is disrupted by the brass, no, which is not disrupted by the brass. Brass is an alloy. So brass is not added to zinc. Another element is added, which is a copper. Copper and zinc are mixed together to form this alloy. So you cannot mention this part. So the ideal answer whenever you are referring, see, first point you will refers to that they exist in a layer, and in alloys their layers like different sizes of atoms are there, and as different sizes, so layers cannot slide over each other or slip over each other. That's why alloys are harder. These are the 3 points you should include. Then this question, which is like totally related to extraction of a zinc in the blast furnace, is not part of the syllabus anymore. Part B, name the alloy formed when a zinc mixed with a copper. What we call that alloy? Just now we discussed. So we call that as a brass. Copper is a transition metal. It can have a variable oxidation state. State two other chemical properties. Colored compound, right? What else? Used as a catalyst. A compound of a copper can be used to test the water. What compound is used to test the water? So copper 2 sulfate. Don't forget to write the valency of a copper, and don't forget to mention anhydrous. Because copper 2 sulfate can be hydrated or anhydrous. So it is anhydrous copper sulfate. And anhydrous is white in color. In the presence of the water, it will turn blue. In part E, potassium is reacting with copper sulfate. Potassium iodide is reacting with copper sulfate, gives copper 1 iodide, iodine, and potassium sulfate. What is the charge on the copper 1 ion? So how we can work out, because in copper one, if they have there is no number written, it means they have the same valencies. So because iodine is -1, so copper should be +1. In terms of electron transfer, why copper is reduced? What is the meaning of reduction? It's a gain of electron. Identify reducing agent. The substance which oxidation happen is a reducing agent. Which substance oxidation happen? Because copper is reduced here. Because copper is +2, become copper +1. So this change is reduction. Why the copper is reduced? Because it was reacting with potassium iodide. So this was page 16 for the metals topic.